So let us record it. So let's record this. This is the topic chemical equilibrium. So chemical equilibrium, this is chemistry topic. Man deal chestunam. So what is this? Basically chemical equilibrium. So chemical equilibrium, it is to study the chemical reactions. This is the concept of study of chemical reactions. Chemical reactions. So chemical equilibrium is about the study of chemical reactions, and it talks about feasibility. Feasibility of a chemical reaction. It talks about the feasibility of a chemical reaction. Next, to what extent does the reaction proceed? Does the reaction proceed? So these are the things which we study. Rate at which the reaction proceeds. Another aspect is the rate at which the reaction proceeds. So these are the aspects we'll study in chemical equilibrium. You can make a note. And also one can study the another point what we have is that we study mechanism of a reaction. We also study the mechanism of a reaction. These are the aspects what we study. So make a note, Amma.
Noted, sir.
Okay, good. Now, what are the next points we have? So it is even before we conduct a chemical reaction, the feasibility of the reaction can be established. Okay, so it's like before conducting the experiment. So the experiment what we are going to talk is about a chemical reaction. Okay, we can predict, one can predict the feasibility, one can predict that whether this reaction happens or not. So that one can predict whether this reaction happens or not. Okay. So for this prediction, we use something called delta G, which is called Gibbs energy function. Gibbs energy function, we use this. So what does this Gibbs energy function will say is that if the Gibbs energy of the reaction, if it is less than 0, that is if it is negative, the reaction will say it is spontaneous. If delta G of reaction is greater than 0, it would say that it is, if it is positive, that then we'll say that reverse reaction is spontaneous. So such a reaction will not happen easily. Okay, such a reaction can't happen easily. Okay, so it says that if delta G of the reaction is greater than 0, If it is positive, we will say that the reaction cannot happen easily. There are ways we can make it happen. That, and for certain reaction, if delta G of the reaction, if it is less than 0, definitely the reaction will happen. So you can say that the reaction will happen. Reaction will happen. So this is the prediction one can give using thermodynamics. So this is the idea one can give using thermodynamics.
Noted, sir.
Okay, good. Next. Now, what is the role of chemical equilibrium? So the role of chemical equilibrium is that we can study to what extent a chemical reaction can happen. A chemical reaction can happen. So that can be studied by using the concept of chemical equilibrium. So to what extent the reaction will happen? That means that suppose A goes to B, A goes to some products. Suppose this is happening. So we will say that the entire A may not be getting converted to products. Let us say 90% of A is converted to products. So 90% product formed, 95% product formed. This is the way we talk about a chemical reaction. So this 95%, all these things will tell about to what extent the product has formed. This is what it says, that to what extent the product has formed. Product has formed. So this is dealt by the concept called chemical equilibrium.
Yes, sir.
Yes, next one. Now, the next aspect what we need to study about the chemical reaction is that the speed of the reaction. Speed of the reaction. The speed at which the reaction will happen. Okay. And the mechanism, speed of the reaction and mechanism. In what way? Mechanism means in which way the reaction is happening. The mechanism of the reaction. So these two aspects are studied by using the concept of chemical kinetics. By using the concept chemical kinetics. By using the concept of chemical kinetics, we can see this.
Yes, sir.
Okay, now we have a definition called irreversible reaction. Irreversible reaction. So what is an irreversible reaction? It proceeds only in one direction. Only in one direction. That means if A goes to B, B is a product. Once the reaction happens, that's final. So suppose you burn a paper, suppose burn a paper. you got smoke. You got smoke. And now if I ask you to take the smoke and bring the paper back, suppose if I ask you to do that, you cannot do that. Unless some person is having a magic, you cannot bring this back. So this smoke, once it is done, it's done. So you cannot reverse the process. Reverse is not possible. We don't have the technology to reverse the process yet. There may be a technology which can reverse the process and bring back the paper. I don't know if such technology will come in future. But as of now, the smoke, once it is formed, you can't bring it back. You can't bring the paper back. So such a scenario is called a reversible reaction. You can make a note of it.
Yes, sir.
Yeah. Next one. So there are certain examples of how do you identify a reversible reaction? How to identify an irreversible reaction? Irreversible reaction. How do you identify an irreversible reaction? The first thing is that if one of the product which is formed escapes, if one of the product which is formed escapes, then you can say then the reaction would be irreversible. Irreversible. So for example, you can take the decomposition of CaCO3, calcium carbonate, if you take and then heat the calcium carbonate, you will get calcium oxide and carbon dioxide. Okay, now carbon dioxide is a gas which will escape out. So if you see such thing is happening, like it's a case of decomposition reactions. Decomposition of a solid. Basically, if you consider a solid like carbon, this is calcium carbonate, and then the solid decomposes to form the calcium oxide and carbon dioxide. Carbon dioxide is a gas which is escaping out. In such a case, the reaction, whatever you take, that is proceeding in the forward direction. So such a reaction is a reversible reaction. If you can trap the CO2, maybe we can reverse that. There are ways we can do that. But in general scenario, once you heat the calcium carbonate, you will get calcium oxide and carbon dioxide. The carbon dioxide, whatever has formed, it will escape out. Once it is escaping out, you can say that the reaction is irreversible in nature. Noted, Amma?
Yes, sir.
Yeah, very good. Now let's move on. So did I get no? One turned up. Fine. Fine. The next one. So another situation what we talk is that so another reaction where it is completely converted to products. Okay, another situation we can think of is to KCl O3, and again if you heat this KCl O3, you get the KCl and oxygen. So this is one that produces oxygen. So here the oxygen is produced. So here the completely, so again you see this oxygen gas is evolved over here, something is escaping, that's a reverse, there's a irreversible reaction, you can see that. And now this is complete, you can achieve 100% conversion of KClO3. you know, we have achieved 100% conversion of 100% conversion. We have achieved for CaCO3 in our laboratory. We have achieved this CaCO3. When we heat, you get CaO plus CO2. You will get 100% conversion in the controlled atmosphere. And we went up to the temperatures of 850 degrees centigrade, and we got this conversion done. Very nicely, we got this done. And now that it's not just writing in the book, I am telling you, it is true that once something escapes out like this, you can achieve the 100% conversion. So this we checked by weight, not even with a single decimal is out. It's a perfectly we got this particular conversion of calcium carbonate. You can make a note. Next one. Another type of reactions is what is like if a solid separates out of a reaction. If a solid separates out of a reaction, in that case also you get a reversible reaction. So suppose let's consider the situation of barium chloride on treatment with Na2SO4. So which is sodium sulfate, you get barium sulfate, BaSO4, and which will precipitate out. So which means that these are aqueous solutions. Obviously, barium chloride aqueous solution. If you mix with sodium sulfate aqueous solution, you get barium sulfate precipitate. So when I put a down arrow, that's called a precipitate. Followed by you get NaCl. Of course, when you get NaCl in aqueous solution, it will be in the dissolved state. So barium sulfate will precipitate out. This reaction, when the solid separates out like a precipitate, when such thing happens, that is a reversible reaction. So whenever you see some kind of precipitation, that is an example of a reversible reaction.
Clear, sir.
Okay, right. And now, what is a reversible reaction? So let's check what is a reversible reaction. So a reversible reaction is something where A goes to, let us say, some products, it gives out the products B plus C. And here the B and C, again, they combine to form A. That means the reverse reaction can also happen. That is, the reverse reaction can also happen. So in such case, when you see such kind of reactions, that means it's not just A goes to B plus C, B and C, they can combine together to form A back. So such a condition is called a reversible reaction. Earlier we have seen a reversible reaction, and we are going to see the irreversible reaction. Earlier we have seen, now we are going to see reversible reaction. Okay, so let's take some examples of the reversible reactions. So one of the thing is that, so how to write the reversible reaction is like this kind of arrow marks we put. So such, if you put such an arrow mark, that's a reversible reaction. Irreversible reaction generally will have this kind of arrow mark, and reversible reactions will have this kind of arrow mark. Now let's move on. Now let us see some of the examples of the reversible reactions, which is N2 plus 3H2. This is the formation of ammonia to get 2NH3. See, this is a gas, this is a gas, and this is also a gas. So these two gases will combine to form 2NH3, that is ammonia. This is ammonia. Now ammonia NH3, it can decompose back to form these two. So that can also happen. So that is a kind of reversible reaction. And next one is PCl5, phosphorus pentachloride. Phosphorus pentachloride, when it can decompose to PCl3 plus Cl2. It will decompose to PCl3 and Cl2. Okay, gaseous state. Okay, you can PCl5 gas. You can think of the gaseous state. It goes to PCl3 gas and Cl2 gas, and these two can recombine to form PCl5. So these things can happen. This is possible. So such a reaction is a reversible reaction. Okay. Next one. Next one is sulfur trioxide is another example what we have. SO3 sulfur trioxide formation, that is 2SO3 that can decompose to SO2 and O2. So that is, you can say that 2SO2 4, and again, yeah, 2SO2 plus O2 gives 2SO3. So that's everything is balanced, I hope. Yes, it is balanced. And another reaction is that H2 gas. Okay, SO3 gas here, everything is a gas right now. And now H2 gas plus I2 gas gives rise to HI. Okay, we take the gaseous state itself. So 2HI gas. So this is also a irreversible reactions. So these are some of the examples of the reversible reactions. Okay.
Clear, sir.
Yeah, clear. Yeah, 1 minute. 1 minute. Just a minute, ma'am. Coming.
Okay,
Yeah.
sir.
Now, what are the conditions? Now, what are the conditions? What are the conditions to conduct? What are the conditions to conduct a reversible reaction? A reversible reaction. What are the conditions to conduct a reversible reaction? So that is the thing. First thing is that you need to perform a reversible reaction in a closed container. That is very important. Why? So you can understand the reason. One thing, see that the reactions, they are proceeding via gaseous states, right? It is a gas. So unless you have a closed vessel, all the examples what we have taken, they are all gases. Unless you perform them in a closed vessel, gas will escape, right? That is the basic idea. Gas will escape. So because the gas escapes, you have to seal that gas inside some closed container. That is obvious. So in order to, so if the products are escaping out, you can't conduct the reaction. You can't conduct the reversible reaction. So you don't want the products to escape. So why the reason you don't want the products to escape? We don't want products to escape. We don't want the products to escape. So such a thing is the situation of a reversible reaction. Okay, right. The next one. Next important point. A reversible reaction never goes for completion. Never goes for completion. A reversible reaction never goes for completion. Next point. Now, another important point, when we conduct a reversible reaction in a closed vessel, when we conduct a reversible reaction in a closed vessel, by taking the reactants, the rate of forward reaction, is maximum, the rate of forward reaction is maximum, and the rate of backward reaction is almost zero, initially. So at the initially means at the time t is equal to 0. So suppose you have taken all the reactants in the closed container and kept all the reactants together, and that is a situation we call it as zero time. We just started the reaction. That is at the start of reaction, especially at the start of reaction. So if the reaction is just about to start, the backward reaction rate is 0. So reaction about to start, reaction just started, rate of backward reaction, let us call it as RB, that will be 0. Rate of backward reaction is 0. Reaction just started, that means reaction just started means we set the time to 0. At time t is equal to 0, reaction just started, you can say the rate of backward reaction, because no product has formed yet. The products are about to form, right? So in such scenario, rate of backward reaction is 0.
Clear, sir.
Okay, clear everyone? Now let us move further. Now we allow the reaction to proceed for some time. Reaction continues for some time. And at some point, we have a situation that rate of forward reaction, is equal to rate of backward reaction. So rate of forward reaction is equal to rate of backward reaction. At certain point, we'll achieve this one. So such a situation is called equilibrium state. So such a situation is called equilibrium or chemical equilibrium. It is also called equilibrium state. This is the study what we are going to do.
Noted, sir.
Next one. All the reversible reactions, all the reversible reactions will reach equilibrium. All the reversible reactions will reach equilibrium. So this is the point.
Noted, sir.
Now, next one. We talk about two kinds of equilibrium in general: homogeneous equilibrium, and heterogeneous equilibrium. These are two things which we study. So it is a situation. What is a homogeneous equilibrium? When the reactants and products when the reactants and products are present in the same phase, when the reactants or products are present in the same phase, the equilibrium state is known as homogeneous equilibrium. Homogeneous equilibrium is known as homogeneous equilibrium.
Here, sir.
Fine, good. Next, let us see some examples of homogeneous equilibrium. So that is N2 gas plus 3H2 gas gives 2NH3. So observe this, the reactants and products both are in gaseous state. So such a thing is called homogeneous equilibrium. Next one. So let us take another example, 2SO2 gas plus O2 gas, which gives us 2SO3 gas. So such a thing is called homogeneous equilibrium. Next, N2 gas plus O2 gas, which gives 2NO gas. So such a thing is homogeneous equilibrium. These are some of the examples which you can remember. Next, noted these reactions.
Yes, sir.
We have some more examples. 2HI gas, which gives H2 gas plus I2. HI is hydroiodic acid. So that is this equilibrium we are talking about. Next one is PCl5 gas, which gives PCl3 gas plus Cl2 gas. So this is again homogeneous equilibrium. Next, another thing is a liquid equilibrium we are going to see right now. That is CH3COOH, that is acetic acid. That's a liquid. So on reaction with ethyl alcohol is C2H5OH, that's the formula. And you get CH3COO C2H5, which is called an ester. This is called ethyl acetate, which is an ester. and that is also a liquid. By elimination of water, that is also liquid. You see, everywhere, everything is a liquid. So that is an example of homogeneous equilibrium. So in the examinations like NEET, you can see MCET or NEET kind of examinations. They can ask you what kind of equilibrium, which of the following is a homogeneous equilibrium. Identify the options. So for such questions, you can see this kind of, or otherwise nowadays they are asking matching type questions in the examinations. So in the matching type questions, you have to identify which is homogeneous and heterogeneous equilibrium. How do you identify if everything? Homogeneous equilibrium means in the products as well as reactants, everything is in the same state, or in fact it's called the same phase. Phase means solid, liquid, or gaseous phase. For your level, we'll say like this: it's a solid, liquid, or gaseous phase. Later, the phase is actually a different concept. Okay, so for now we'll talk about the solid, liquid, or gaseous state. So in the everything is in gaseous phase, you see in the first reaction. Second reaction, everything is in gaseous phase. Third reaction, everything is in liquid phase. So that's a homogeneous equilibrium. So I hope noted all these things. Okay. Now let's see.
Yes.
Let's see the next one. Heterogeneous equilibrium. Heterogeneous equilibrium. So what is this heterogeneous equilibrium? If the products and reactants, present in the reaction, are in different phases, it is known as, or such an equilibrium. So reactants and products that should form a reversible reaction and equilibrium should exist. Such an equilibrium is known as, such an equilibrium is known as heterogeneous equilibrium. Heterogeneous equilibrium. So this is the crux, what you all have to know, first of all. So this is the introduction to the chemical equilibrium. We will I will give you some more examples of the heterogeneous equilibrium. Noted. Good. Now, what are the examples of the heterogeneous equilibrium? So let us take this one. Suppose if I was talking about this particular reaction. If I do this in a controlled state, I will get the equilibrium. So if I do this reaction in the closed vessel, I will get CaO plus CO2. So here, if you observe, this is gas, this is solid, and this is solid. So solid and gas together, they are present. So that's an example of heterogeneous equilibrium. And another example is that NH4Hs. So this is another example. Solid, and then so this one on heating, you get NH3 gas and H2S gas. Okay, H2S is hydrogen sulfide. So here, this is also an equilibrium. These two gases will combine to form a solid. So it's a very nice example. So such, it's like a solid, it will disappear and it will form gas. So such a scenario this is. And these two gases will combine to form a solid there. So it's a beautiful, wonderful thing. If you can see this, I will check whether we have some videos on such a reaction on YouTube, whether NH3 and H2S, they do combine to form this NH4HS. Such sort of thing, if it is happening, is if there is a reaction, if someone does that, that would be a great video, right? So that is an example of a heterogeneous equilibrium. Okay. Now, what are the characteristics of equilibrium state? That we will summarize and then we'll close today. What are the characteristics of equilibrium state? Characteristics of equilibrium state. Characteristics of equilibrium state. So what are the characteristics of equilibrium state? This is what we have to see. The rate of forward reaction, forward reaction is equal to rate of backward reaction. Rate of backward reaction. So this is the first and foremost thing we have to observe, whether the rate of the forward reaction is equal to the rate of backward reaction. And the properties like that is properties of the system. Properties of the system we have considered. What are the properties of system? They are like pressure, concentration, density, color. They remain constant. Okay, they remain constant. They remain constant. Properties like system, properties of the system like pressure, concentration, density, color, all these things, they do remain constant for an equilibrium reaction.
Noted, sir.
Very good. Now, point number 3. Equilibrium state can be reached either from the products side or from the reactants side. It can come from either side. Equilibrium state can be achieved from the either side. It can come from the product side or it can come from the reactant side. Noted?
Yes, sir.
Yeah. Next one. Equilibrium state. Equilibrium state is a dynamic state. Dynamic state. What is dynamic state? Dynamic means it will be continuously moving. Such a state is called dynamic state. No reaction stops. So neither forward reaction nor backward reaction stops. Equilibrium state is a dynamic state. Neither the forward reaction nor the backward reaction stops.
Noted, sir.
Hence you can say, hence concentration pressure, etc. remains constant. Remains constant. Hence, concentration, pressure, etc. they remain constant. This is also called thermodynamic equilibrium. Thermodynamic equilibrium. So this is also called thermodynamic equilibrium. This is also called thermodynamic equilibrium. This is also called thermodynamic equilibrium.
Noted, sir.
Next one. How do you alter the equilibrium state? So the question is, how do you alter the equilibrium state? Equilibrium state can be altered by changing pressure, concentration, temperature, etc. It is possible by doing these things. By changing temperature, pressure, by changing pressure, concentration, temperature, one can alter the equilibrium. Another important point is equilibrium can't be altered by a catalyst. Equilibrium cannot be altered by a catalyst. But the equilibrium state is rapidly achieved in the presence of a catalyst. So I am writing in short forms. I hope you can understand. Equilibrium cannot be altered by a catalyst, but the equilibrium state is rapidly achieved. That means we will reach really fast. That means equilibrium is reached. So what the catalyst does is, once you note, what the catalyst does, it will not alter equilibrium. That is most important. It will not alter equilibrium. That means it will not disturb the equilibrium. It will help to reach the equilibrium faster. Equilibrium rapidly, or you can say faster. So this is the crux. This is the thing what I want to tell you, students, today. So tomorrow we will cover the topics, law of mass action and so on further. And now this one which I am recording, I will post it on the YouTube so that you can have a look at it. Some of you have joined little bit late, so that part you can see in the video which I post today itself. Now itself I will post. So this is where we'll close today's session, and tomorrow we continue almost at the same time. Please respond to the messages what I'm posting. So tomorrow almost at the same time, 7 to 8, we'll have the class. Thank you all. This is where we'll close today. Bye. See you.